All right, this question is a little bit different than the other ones with the force of tension. In the other ones, the force of tension was your upward force. So normally we were using force of tension and it's connected to a box or crate or an elevator, whatever the case may be. This question is slightly different in that this looks at Cade standing in the elevator by himself. So he's standing on a scale to see what happens. So if you were standing on a scale in an elevator, when it started to go upward, you would want to stay in place because of Newton's first law. So the scale would get pushed down and would read a higher number. So the question is, what would the scale actually say? So it's the same scenario as the other questions. I still have the free body diagram, which is, in this case, Cade. Cade's standing on the scale, and it's not tension anymore that's pulling upward on him, making him accelerate. It's actually the scale is what's directly connected to him. So the scale is how we will be able to read it. So F net is exactly the same scenario. All the forces up. So the force of scale minus all the forces down, which is gravity. I make my substitutions, of course. The scale doesn't change. This is mass times gravity. Cade's actual mass is 80 kilograms. The acceleration going upward is 1 meter per second, so this is the upward version. And the force of scale, we don't know, but we're going to find out. And then the mass is 80 again. I can move this for a second. Times 9.8. So when I work this out, I've got my numbers in there. So the force of scale works out to be 864 newtons. But because it's not going to read in newtons on a bathroom scale, it's still the same conversion. So we still divide by 9.8. And we would get the mass, not his actual mass, but the mass that it reads. The mass reading would be, just down a little bit, mass reading is, in this case, 88.16 kilograms. If I go downward, I change this to a negative, that number is going to be smaller. Still divide by 9.8 to convert it, and I get 71 point something, I believe, is the answer when I'm going downward. So it's still the same scenario. Only difference is instead of the tension being the force that makes it move upward, it's the scale that makes it move upward. So a quick example. Hopefully that makes sense. It helps you with the assignment question on the, or the question on the assignment. Thanks.